y minus 2 bracket squared equals 8x. If we compare that with y squared equals 4ax, we can see that the x-axis remains as is standard, but the y-axis is shifted. So the vertex happens when x is 0. So if we think of 0 in here, this will be 0. 8 times 0 is 0. Y would need to be 2, wouldn't it? So this is our vertex, and it's the customary parabola going in this direction here. So here's our axes of the parabola, and we'll just draw a parabola out from here then, out from the vertex like so. So there's our parabola then. So tangent to normal at 0, 2. So here, let's differentiate. So function of function, 2 lots of the something, multiplied by the something differentiated. This will go to 0, the constant, and this will be just differentiate to dy dx, is equal to x goes to 1 and 8 lots of, so that's 8. That tells us that dy dx is equal to 8 over 2 bracket y minus 2. We've moved this from times on one side, this object, down to divide on the other. There's a 2 common top and bottom, so divide by 2 top and bottom, we get 4 over y minus 2. Now what's interesting here, at p, which is 0, 2, dy dx is, it's undefined because when you put 2 in, you'll get 4 over 0. So it's undefined. So looking back at the curve, it's undefined because it's vertical, it shoots off to infinity. So by inspection, just looking at the curve then, we can see easily what the tangents, we see that, so the tangent here at P is that vertical line here, which I'll put in green. So the tangent is there. And the axis that we pointed out earlier on turns out to be the normal at that point, doesn't it? At the vertex, because the point is the vertex. So what have we got then? The tangent. I'll just squeeze it in down here. So the tangent is this line here, which is x equals 0. And the normal. And the normal. And that would be y equals 2, wasn't it? Because that was that line there, was the normal. Okay, good.